to go.
Oh, sweet nectar. Thank you so much for having me here, everybody. Thank you so much for coming here to this wonderful show. And thank you, Dr. Subramaniam and Sharat for, inviting me. You both have known me for closer to a decade than not. So I would have expected by now that you would have exhibited the common sense to not invite me to a nice classy event like this. And yet you persisted. So I appreciate that. It's actually a really fortuitous, really amazing day to do this. Today is 24th of March, which as it happens is the what is it now, 16 year anniversary of the first release of Spring. So Spring was in sort of development and incubation for a number of years before that. So I started using it before that, back in 2002, but it went GA. The first release went GA on 24th of March 2004, which I think is pretty cool. So to be able to talk to you all about Spring today, 16, 17, 18 years later, and still have it be more relevant than ever, that's a unique and privileged position to be in, and I'm really grateful for the opportunity. Why is there beeping? Let's chat. Yes, you will. Okay, good. I'm gonna ignore the chat until we get to the end of this thing. I'm assuming that somebody will send me an off bandwidth, out of band message to tell me if my feed has ended or something abruptly for no reason. Okay, good stuff. So we have very little time. We have what did we say, 50 minutes and very little time to get this done. So let's do it. My name is Josh Long. Thank you so much for being here. I know that you have a lot of places that you could be right now, and goodness, there are a lot of opportunities right now. Now it's no longer just a function of what conference you're in and what other tracks are competing with your track, but now it's a matter of what other virtual conferences you're in, and because they're so much cheaper, it's much harder to find a really good one. So I was very glad to see that Dr. Subramaniam and Sharat pulled this thing together so quickly, so agilely. I guess that is, but that's to be expected given he's the author of the Agile developer, right? So this is a really, really great show. I've just been enjoying all the talk so far. My name is Josh Long. If you have questions, when you have questions, obviously we have some time at the end of this together, but don't confine yourself to just those 10 minutes, my friends. We are in this journey together. And goodness knows, if I didn't have a lot of free time before, I certainly do now. So don't hesitate to reach out to me on Twitter, on email. Those are my coordinates. You can find me there. A little bit about myself. My name is Josh. I work on the Spring team. I've done a bunch of videos. You can find these on Safari. They're live lessons videos. These are 5, 6, 7, 8 hour long deep dive introduction to various topics. I've got a book called Cloud Native Java. I've got a podcast every Friday where I interview people that are smarter than I, including, but not limited to, the good Dr. Subramaniam, among others. And so, when I say people that are smarter than I am, it's a very, very low bar, but I do manage to get some impressively smart people despite that. So please join us for that. Every Tuesday, that's today, friends, that's today, I do a roundup called This Week in Spring on the spring.io/blog. And it's just all the news that's fit to reprint. It's been that way ever since January 2011, so 9+ years that I've been doing this. And of course, every Wednesday I have a Spring Tips video. It's usually 20 minutes to an hour, sometimes a little bit more. It's just me at some corner at the keyboard, exploring some corner of the ecosystem, some bit of arcana in the Spring ecosystem that I couldn't do as a general talk, but that might be interesting if you want to sort of opt into watching it, if you want to go and explore a little bit more. Usually my talks are breadth, not depth, but this is quite the opposite. And of course, I'm writing a book called Reactive Spring, and that, my friends, is the topic of our talk today. So you can buy the book, you can read it. It's available now. It's not done, but you can buy it and read it now. Or you could just stick around for this next hour, and hopefully you'll have a sense of what's possible. And given how smart you all are, and given how entrepreneurial you all are, I know that you can, connect the dots for yourself if you want to. So let's get to that. What are we here for? What are we talking about? Well, we all want to handle more users, right? We all want to make better uses of the resources in our systems and our services. And that's made more difficult today by the way that we use threads on the JVM. Threads are expensive. You've heard this before, I hope. Each thread takes some non-trivial amounts of space and RAM for each for each operating system thread. And unfortunately, if you log into most existing systems that use the JVM to build services and you look at the CPU usage, you'll notice that the services are mostly idle. All the threads are in a wait state, waiting for something to happen that's not going to happen anytime soon. They're idle, and yet they're not able to handle more requests. CPU usage is low, but they're not able to handle more requests because they're waiting, and they can't create more threads because that's actually a very expensive thing to do. So we want to fix this, right? And if we look at the threads, I'll bet you dollars to donuts that most of them are in a wait state, waiting for input and output. This is a problem, right? Because if you look at the traditional approaches to input and output, they use Java IO input stream. Imagine that. Imagine using Java IO input stream. I'm sure you've done this 1,000,000,005 times in the last week. You call Java IO input stream.read. The client thread stalls. It waits for the next byte to be returned from that read call, right? So while we're sitting there waiting for the next byte to arrive, we don't even know if it'll arrive. We shouldn't write code that's so failure ridden, right? We don't know when the bytes will arrive, and we don't know if it'll arrive. And that's problematic because in the meantime, we're wasting that thread. We're monopolizing that thread. And such code is particularly problematic at scale. So what we want is some way to not monopolize that thread that other things in the system could be using. What we need is a programming model that flips that around, that gives us the ability to say, hey, when there is data available, give me a callback, or actually at the lowest levels, give me an interrupt. Give me the ability to continue processing other work while I can, but in the meantime, don't monopolize this thread. Sharing is caring. And that, my friends, is the crux of reactive programming. It gives us a programming model that lets us contend with latent, potentially unlimited, potentially faulty, and almost certainly asynchronous streams of data. This is a much more natural way to view the world when you think about it, of course. It's a result of looking at how most people work with data over the network, over the wire, over any kind of input stream, and realizing that most of it is just latency, right? It's the network being fallible. It's the occasional connection going out. It's the delay it takes for processing to begin on some other microservice. It's the fact that your other microservice has stalled and you're waiting for nothing, that you're waiting for something that's never going to arrive because it's taken a nosedive, right? This is the nature of moving to microservices. So we understand what we're trying to do. We're trying to move work like synchronous IO away, and we're trying to replace it with asynchronous things. When it comes to IO, we can use asynchronous IO, right? That's a natural thing, but most of us don't want to write a code, certainly not for our services and for data access and for our security and for our web tier in terms of input streams and output streams. That's far too low level an API. And similarly, I don't expect that most of us would want to use Java NIO, which supports asynchronous IO. So what we need is some sort of abstraction that gives us the way to deal with and to model asynchronous, potentially latent, unbounded streams of data. This is where the reactive stream specification comes in. It's a common ground set of interfaces defined for modeling this kind of data. It was a result of work, a collaboration between a lot of different organizations. The Spring team, then at Pivotal. By the way, we're now at VMware. We're part of the Tanzu business unit. So if you see Tanzu and you see Spring, it's the same people as always. We've just changed the name on the paychecks. That's all. So Tanzu is that's awesome, right? I hope you'll keep that in mind. Tanzu. Anyway, so we want to be able to use this abstraction, which is, as I say, a collaboration between the Spring team, then at Pivotal, now at Tanzu, the Eclipse Foundation, right? Lightbend, then called TypeSafe. Who else? Oh, Netflix, of course. So these are common ground interfaces that were extracted out to define how we can model asynchronous, potentially latent, potentially unbounded streams of data. They're so useful that these core interfaces have since been incorporated into the JDK. So if you're using Java 9 or later, and goodness knows you should be, if you're using now Java 9 or later, then you already have access to these interfaces, identical interfaces, package notwithstanding, of course, within the JDK. So they're under Java util concurrent flow, where flow is a top level type. These types are useful, but I like to think of them as discontiguous Java arrays. They're arrays that allow us to basically hold on to a bunch of data, but that's about it. You get the basics like range checking, sort of, to borrow the metaphor, to extend the metaphor perhaps a little bit too far, but nothing else. You don't get operators. And so where Java arrays certainly underpin everything we do today in the JDK, I think most of us don't work at that low level. Most of us are hopefully able to take advantage of things like Java 8 streams or at the very least the Java collections API, much higher order abstractions that work with that. Similarly, when it comes to reactive programming, we have higher order abstractions that give us things like operations, filters, flat map, things that we can use to work on or operate on the streams of data. This is where individual projects led by different companies like the Spring team at Tanzu, like Netflix, and RxJava, like Akka Streams and Lightbend, like Vertex and the Eclipse Foundation. All these different projects give us these higher order operators. That is useful in of itself. It gives us a lot more power to process data. But even there, I would say we're not nearly where we need to be. What we want is something that allows us to build, the everyday business bread and butter kind of software that we care about, the software that allows us to ship into production and deliver business value and go home happy in a job well done. And for this, of course, we have Spring. So Spring builds atop Reactor, which is from the Spring team, and it in turn builds atop the reactive stream specification. And we can now use Spring Boot, and Spring Data, and Spring Security, and Spring Cloud to build end-to-end reactive systems and services. And that journey, my friends, that's the journey that we're going to walk today, of course, by building software. Now, obviously, we have a lot of ways we could do this, but what we're going to do is we're going to go to my second favorite place on the internet after production. Obviously, I love production. You should love production. You should go as early and often as possible. But if you can't, then you can begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If you suffer from indigestion after a long night of alcohol abuse and PHP, start.spring.io. So what we're going to do is we're going to use the latest and greatest version of Spring Boot, Milestone 3, which was just released last week. You know why I'm going to do this? Because I can. It's been days. I've had a lot of free time. I've made sure this works. I can do that. Although, to be fair, I usually do my talks on the stage, and I'm usually the first one to just do hashtag YOLO and choose the latest one, even if it just came out half an hour before my talk, because usually it just works. And if I ever have egg on my face, it's usually because of me as opposed to the software, which is a nice change of pace. So we're going to build an application. We're going to call it Service. We have a few choices to make. Obviously, the first choice of which is the choice of packaging. How do we want to package our application? Here now we have a couple of obvious choices. I'm going to leave the default here, but then we have the choice of Java. Which version of the JVM would you like to use? And my friends, this choice is one that bedevils a lot of people. They don't know when and where to choose which option. So I'm going to do my level-headed best here now to explain when and where to choose which. You have before you 3 choices, but I say that with air quotes, and I hope you won't let the lack of a camera stop you from perceiving those air quotes. You really only have 2 choices. Okay, one is there, but it's not really a choice. I cannot more stridently discourage its use. That choice that you should not use is Java 8, right? This is the old version of Java. It's inexcusably old. It's ancient, creakingly old, way past its prime, stinky software. I would not use that with a 10-foot pole. So that leaves us, my friends, with but 2 choices, Java 13 and Java 11. Java 11 is the long-term supported version of Java. This is a nice place to park your code for 3 years and get maintenance. If you're a coward, if you don't feel that you can upgrade Java from one version to another in 6 months. Now, if you're using a modern cloud platform, most of them will happily conveyor belt you from one version of Java to the other, right? And so you can just use the new version and be assured that you're going to be automatically moved and so on to the new version. I would do that if I could. And if you can't, then use Java 11. But since I can, I'm going to. So we're going to use Java 13. Java 13 is a much better version of Java. I'm not yet using Java 14. That's the version you should be using, but it's not yet supported there on Spring Boot. That said, I love Java 14, and I even do videos because I love Spring, and I told you about those Spring tips. I just did a video last week, or I guess that's almost 2 weeks now, called Spring Tips, where I looked at the use of Spring Boot 2.3 and Java 14. So it can definitely be done. It's just not one of the things that's supported out of the box just yet, okay? But you should definitely encourage others to do so. And you can watch this video for details on the small trivial changes that are done to support Java 14 and all the amazing features that are, in some cases, preview features like records and multi-line text strings and so on. For now, I'm using Java 13. Okay, so I'm going to build an application today, my friends, using the reactive web support. I'm going to use Lombok. I'm going to use the reactive MongoDB support. I'm going to use R2DBC. We're going to get to that in a second, but suffice it to say, it's an abstraction for SQL data store access. I'm going to use Postgres, which is a type of SQL data store I've got running on my local machine, in addition to the NoSQL MongoDB. And then I'm going to use Lombok. Okay, so having made those choices, I have a reactive web, MongoDB, R2DBC, Postgres, RSocket, And I think that's it. I think that's enough. I'm happy with my selections. I've got all the different choices here. We've established why you need to use jar. That's a very common sense, same default thing to do today. Most people are going to use that anyway. And we've established why you should use the latest and greatest version of Java wherever possible, because Java is awesome. It's not just the technically better choice, my friends. It's not just technically better to use the latest and greatest version of Java. It's also morally better. Again, ask yourself, ask your children if they're prepared to accept you for using Java 8 in production, if they're prepared to have that conversation with you. I don't think you're gonna like the response you get, my friends. I would encourage you to stick to the latest and greatest. Now, MongoDB, Reactive Web, RTDBC, Postgres, RSocket, great. So let's hit generate, and that'll give us a new project, which I'm gonna then open up here. So CD downloads, and I've got, get rid of all that, generate, here we are. I've got a new zip file. I'm going to open this up in my IDE, and it doesn't all that much matter what IDE you use, so long as it supports all these things. If you're using IntelliJ Ultimate 2020.1, I think, it also supports Java 14. That's a good experience. Okay, so here's our application. Downloading the internet. Alrighty. And we're going to call this service. So what we're going to do is we're going to write an application that writes data to the database. For now, we're going to use MongoDB. I've got that running on my local machine in the background there. So I'm going to comment out that. I'm going to comment out the Postgres driver. Okay, I'm going to comment this out. Here we go. And I'm going to tell Maven to automatically auto import all changes to the build. All right. Now, here's my application. We're going to save data to the database. Let me make the font a little bit larger, my friends. Here we go. 18, good stuff. We're going to build a class that writes data to the database. So reservation, and it's going to be a entity like so. Private string ID, private name. We're going to give it an ID to signal that it should be mapped to the primary key in the document. When we say document, I mean a single row in a collection. A collection maps more or less to the idea of a table in a SQL data store. And so there you go. There's the essence of what I want to express. But as I don't have Java 14 records and I'm not using Kotlin and its case classes or Scala and its data classes, I need something like Lombok. Lombok makes it trivial to, oh dear, it's not here. Did I disable its inclusion in the build? That's okay. We can do this old-fashioned way with our fingers. Okay, so Lombok. Did I not add this? When in doubt, my friends, you can always go back here, specify Lombok, and then explore, and that'll give you the proper coordinates for the dependency you're looking for. So here we go, copy and paste that, paste. Okay, good. So there we are. There's our build. It's updating now. Now I can use Lombok, presumably. Good. At data, at all args constructor, at no args constructor. Good stuff. So now I can actually persist that entity into the database. Reservation repository extends reactive CRUD repository. Okay. Managing entities of type reservation whose primary key is of type string. And this repository is just an interface. We don't have to implement it. It'll be done for us by the framework. And we can see that it provides some signatures that we can then expect to be present in our actual realized manifested reified service, or repository rather. These signatures are fairly straightforward. They are all fairly accessible if you've ever done any kind of data access before. So save all, find by ID, count, delete, etc. Check if it exists. All these things are fairly straightforward. What may be unique and interesting and novel are the parameter types, the first of which is the aforementioned reactive streams types. Org reactive streams publisher. A publisher publishes data asynchronously out of band to a subscriber. A subscriber listens for that data and it consumes it. As each record arrives, it consumes it in the onNext method. When there are errors, if there are errors, ineluctably, when there are errors, they are processed in the onError method. And finally, when you're done processing all the data, the onComplete method gets called. Now, subscriber has one other method that I've kind of hand-waved past because I didn't want to focus on that at first, but it's, I think, the most important. It's onSubscribe. OnSubscribe is what gets invoked when the subscriber first connects to the publisher. It is where the subscriber is given a pointer, a reference to the subscription, which it can then use to drive the rate of production from the producer, okay, from the publisher. So the subscriber says to the publisher, hey, I want X more records. I want 10 more records. I want 5 more records. I want 1,000 more records. I want 10,000 more records. Whatever you feel you can handle in one foul swoop without being overwhelmed, without running out of RAM or without overwhelming your system, then you should specify that here. Request gives the client, the thing that's processing the data, the ability to drive the rate at which it does that processing. If it wants to stop that processing, it can call cancel. Now, this is not controversial. This is not a particularly new or interesting thing. It's a very simple idea. It's flow control. If you've ever used TCP, UDP, you've had to think about flow control. What happens when one service on the internet goes faster or slower than the other? That's a very simple thing that's bedeviled programmers ever since there was more than one computer on the same network, okay? So not a new idea, but we've surfaced that as a top level concept in this reactive API. The reactive folks sometimes call this back pressure, okay? It's the same idea, just nice new marketing name. Okay, so now we've got we got 3 out of 4 of the reactive streams types, the 4th of which is processor, a bridge type. It's a source and a sink, a publisher and a subscriber. And that is it, my friends, that's it. It's all, it's just that, just those 2 types. Now, if you understand that, congratulations, you're certified reactive, congratulations. You're welcome to eventually, assuming the virus recedes and travels more palatable, you're welcome to move to Silicon Valley, start up a startup, raise millions and millions of dollars in venture capital money, and then burn it all on lavish, ridiculous parties. You are ready. Now, that said, these types are just the foundational pieces, as I said earlier. So we have 2 specializations. The first is a mono. A mono is a publisher that produces 0 or 1 value. It implements publisher, but it has all these extra wonderful operators. Now, suffice it to say that most of your work will be done in terms of these operators, okay? This is how you manipulate the streams of data. These give you all the usual suspects that you might expect from having used something like Java 8 streams, but they give you considerably more as well, things that you can use to composition, to manage the scheduling of things, etc. We also have a flux. A flux is just like a mono, except that in producing 0 or 1 value, it produces 0 or up to n values, where n is potentially unlimited, okay? It could be an infinite stream. The semantics are what's important here, right? If somebody has a method that returns publisher of customer, and it says get customers, right? Or get customer, or just read, whatever. What are you gonna do? What are you expecting that data to contain, that publisher to give you eventually? That publisher is kind of vague as to the intent that you're being given, okay? If somebody gives you a flux of customer, you can assume that, or you can surmise that they expect you to render a view page, right? This is a table, a grid that has all the information about all the customers. It's an overview page. If they give you a mono of customer, then more likely it's a detail page. It's a single individual customer, and you can look at the details, okay? That's useful. That helps you to make a distinction there. Now, we have these types. They give us the ability to write data to the database. So let's do just that, okay? I'm gonna create an initializer here. Initializer at event listener, application ready event, class, public void ready. And here is a bean we're gonna inject into the constructor like so. I'm gonna use Lombok's annotation there to make that a little easier to synthesize a constructor. And what I'm gonna do is I'm gonna create some names that I'm gonna include into the database. Okay, so I'm gonna use Dr. Subramaniam. Okay, I'm gonna use Sharat. Oops, and I'm gonna use my name is Josh. It's nice to meet you. And now we've gotten the 3 of us. I suppose we should go with some people on the spring team, because I'm running out of names that I have on the top of my head otherwise. So we've got Ria, she's awesome. We've got Bella, she's awesome. We've got Violetta, amazing as well. We've got who else? I'm missing. Oh, Madura, of course, she's legendary. We've got is that 8 yet? That's 2, 4, 6, 7, and 8. And let's just do Dr. Sire. He's amazing too. There's some amazing people. Good. So names, okay? These are just names that I put into a publisher, a reactive stream of names. And I want to visit each one of these and turn it into a new reservation. So I'll say pass in the name, and I'll turn that into a reservation publisher. And I want to save each record in that publisher into the database. And so I could call map. I could do this. I could say reservation repository dot save and pass an R, and that would be okay, but consider what save returns. If you look at the return value for save, it returns a mono of reservation. That is to say, it returns a reactive type. So I'm gonna have map, which takes or aggregates the result of invoking the inner lambda into a container type. I'm gonna have a container type of flux, and each inner type returns a mono of reservation. So I'll have, therefore, a flux of mono of reservation, like so. That is a mind-bending and also really hard to code. I don't want to have to manually, resolve all the inner publishers just to be able to get access to the whole overall stream. So what I want to do is instead to flatten that stream. That's what I'm going to do here. I'm going to flatten it by using flatmap, and that gives me a publisher of reservations. Now, even if I ran this code right now, nothing would happen. And the reason is because, of course, I have no call to subscribe. I need to subscribe to trigger the pipeline, to activate the pipeline. Consider each step in this pipeline as a set of pipes through which water can flow, but unless you turn on the faucet, no water will flow. So you need to subscribe. Now, the problem, of course, is that this is the long form. I wouldn't actually write that code today if I were. If I could, I would just tease it into separate steps in the same pipeline and then just assign that to the same variable. Makes it easier to write, easier to read, and you can see now I've got that. The problem, of course, with this is if I run it more than once, I'll have 8 names and then 16 names and 24 names and so on. So I want to say, let's get rid of the data in the database first. So delete all, that returns a mono. And then after that's asynchronously finished processing, then and only then, I want to process the data in the writer. And then and only then, I want to do a find all. And then and only then, do I want to log out the results, right? I can just call subscribe, or I can call subscribe and tell it to log things as the data comes back. I can use log4j, certainly, right? I can use that, log info. Now let's run this program and see what we get. I like that it takes more time to compile things these days than it does to actually run it. Okay, good. Now, there we are, my friends. All 8 of us, we happy few, it worked. There's our records that reflected in the output in the command line there. If I go here and I grab that ID, and then I can go back to Mongo and I can say db.reservation.find. Okay, here we go. There's all the records. And there's the first one for Dr. That's for Sharat. Oh yeah, that's another great point. Notice that I put these names in a particular order, but they came back in a different order. Sharat came back first, and the ID there corresponds to what we have in the database here. That's because each one of these values, each one of these writes is an asynchronous type. We don't know which one is going to complete first. One would assume that they're all going to complete roughly in the same time, but there's no guarantee there, and that's okay. Right? They don't need to. In this case, it's fine for the runtime to parallelize them. I could do flatmap sequential. That would actually enforce some ordering, but in this case, that would be pointless. I would actually needlessly slow down the system for no gain. Okay, so we've got data in the database. I'm using MongoDB. That's a NoSQL data store, of which there are many. And of course, we have good support for reactive Spring Data implementations, supporting, among other things, Azure Cosmos DB, Google Cloud Firestore, Google Cloud Spanner, Cassandra, MongoDB, Redis, Neo4j, Couchbase, and Elasticsearch. Good stuff, but sometimes people want to talk to a SQL data store. And so, in fact, I suspect most of the time. And so we have an abstraction called R2DBC. It's the Reactive Relational Database Connectivity Abstraction. And there are a number of different drivers, reactive asynchronous IO based drivers that are out there, including one for Postgres. So I've just uncommented the R2DBC Postgres driver. I'm going to comment out MongoDB here, just get rid of it, and I'll drop the document annotation in my thing down there. Keep in mind, this is not a MongoDB document anymore. It's a SQL data store table. So instead of using a UUID, as is the custom for MongoDB, I'm going to use a monotonically incrementing primary key like that. But otherwise, friends, that's all we need to do. So I can just run that code, restart. Oh, it's going to fail because I need to configure the connection credentials. That's true. I forgot about that. So we're going to say R2DBC .url R2DBC Postgres localhost orders and username orders and password orders. Now, there we go. See, we started the application up. Here's all the data in the database. It's been reflected in the output there. And if I go back to my PSQL data store, Postgres database, I can say select all from reservation. And there we are, we happy few. Again, in a different order. There's no guarantees of the orders here. And we don't need it, we don't care, right? As long as they're all there. We do have support for reactive transactions, by the way. And that's a very interesting question if you think about it, because there's no guarantee in a reactive pipeline, that things will persist on the same thread. There's no guarantee that it'll stay on one thread versus another. So we actually have the mechanism that can propagate storage from one thread to the other. As the flow of execution jumps from one thread to another, we propagate that storage for you, that state for you. And that's what we use to do things like distributed tracing, like reactive transaction management, like reactive propagation of security credentials, and so on. That's called the reactor context. And it's a topic in which I could spend a whole lot of time in it for its own separate talk. In fact, I did a Spring Tips video on that, and I'll just leave it to you to find that. But for now, let's assume that we understand what that basically does, and let's move on. The next thing I want to do is build an HTTP endpoint. And here, it would be trivial to build a REST controller and just say reservation, REST controller. Okay, here we are. And I'm going to inject the reservation repository as I did before, and I'll create an endpoint, get mapping, reservations, and publisher of reservation. Okay, and here we go. Return this dot reservation repository that find all, and so on. I could do that, and that would be just fine. And it's fairly straightforward if you've ever used Spring MVC. But since I want to keep this a little bit more concise, and considering that this is just one endpoint that has very, it's a very simple thing, HTTP GET for reservations that returns a publisher. Okay, fairly straightforward. Given that that's the goal, I might choose instead to use the functional reactive style. Okay, so I can say return route dot build dot get / reservations and return a new handler function, return a server response dot body, and here I'm going to inject the collaborating object. Okay, reservation repository dot all rr dot find all reservation dot class. Now we can clean this up. Lambdas go a good deal to clean that up. Okay, and static imports from Java 5, we got that, good. That can just be R, much better. There's the entire HTTP endpoint. And keep in mind, this is a builder API, so I can chain these things together. I can use if, else, all that kind of stuff to chain together these different handlers. I can use delegates. I can use method references rather to just forward the invocation of the method to another object or another bean. So lots of flexibility there, but the result is the same. If I run the code and start up the application again, okay, like so, and I go to the browser, right? Like reservations. It just finished compiling. Come on, there. So there's the data. Okay, there we are. We have 8 records in the database. We have data talking to a SQL data store, and I can hear you collectively go, so, like, who cares, right? I didn't need reactive programming to return 8 records of JSON, of application JSON content. I could have done that yesterday with the servlet API. And JDBC. I don't really need reactive. And that's a fair point. I hear you. I understand what you're saying. What I've just shown you is that you can do what you did yesterday with the same ease. In fact, I would argue a bit more ease, because when you move to reactive programming, everything is a publisher, right? So there's not a separate API for every little asynchronous thing out there, right? If you want to do server send events, it's a publisher. If you want to do WebSockets, it's a publisher. If you want to do, Kafka or RabbitMQ, it's a publisher. If you want to do, REST, it's a publisher. It becomes very easy because you amortized over all these different APIs. The upfront cost of learning reactive APIs is, cheap. It's not cheap and not expensive at all, because you can now use this one set of skills to approach almost everything, right? It becomes very nice. And a result of that is that these APIs now compose very nicely because they are the same thing and they work with each other. They understand each other. So you can actually chain things together that you wouldn't otherwise want to try and connect very naturally. So reactive programming actually makes what we're doing yesterday easier, but I understand you. I understand what you're saying. You still want to see where this thing really shines. It's not just about doing what I could have done yesterday. Where reactive programming really shines is in places where you might have otherwise monopolized a thread. So what can we do? What kind of things monopolize threads? Well, let's consider the typical examples. Suppose you're building an application that does stock tickers, right? Trivial but typical example. I want to update stock tickers. This is one of those things where you really want to avoid having a client create a thread to connect to a socket to get the latest updates. Having that thread there means that you are limiting the number of users that can access your system to the number of threads that you can create on the system. And the reason you create a thread is because you want to keep that socket open at all times, right? What we want is for the client to connect and to be able to get new data immediately. Now, this is expensive. This is a very expensive proposition, but in the world of stock trading, every little bit helps, every little byte helps, every little bit of latency helps, or rather avoiding every little bit of latency helps. Similarly for chat, chat systems. Imagine you're chatting with somebody. It would be a very choppy, very sort of staggered experience if you had to wait 2 seconds for the client to poll the server for any new messages from everybody else in the chat. So instead, what I want is to be able to keep the socket open, okay? So any place where you end up keeping a socket open, this is an example of things that might, in the old world, monopolize a thread. It might keep a thread open. So what's a good example of that? Well, let's suppose I created a service to produce greetings, class greetings service, okay? And here, I'm going to create a reactive stream that produces greetings responses, okay? Greet. And I'm going to only do so given a greetings request, okay? So greetings request and greetings response. And the request is going to have a name in it, and the response will have a message, okay? You must be able to type the names of the types in order to use them. So data at allargs constructor, at noargs constructor. So these are the basics of what I'm trying to do here, right? And what I want to do is I want to now return an infinite stream of responses given a request, okay? Greeting request. So let's look at that signature. Let's look at what it's doing here. I'm going to create an infinite stream from stream. I'm going to use the stream generate builder there in Java 8, and I'll just adapt it into a reactive stream there. So I'm going to say hello request.getName at instant.now, okay? And that's going to produce an infinite stream. It's going to keep going forever in perpetuity, and that's okay. Okay, so we're gonna have an infinite stream, but I do want to be able to see the results as we're demonstrating it. So I'm going to stagger the results there. I'm going to stagger the results by 1 second. I'm going to introduce time, and the reason I can do that is because reactive APIs give you a scheduler. Now you don't always see that scheduler, but it is most certainly there. That scheduler is in play all the time. And I could have used it, for example, back over here when I was running my little pipeline. I could have overrode the scheduler that was in play, schedulers dot, elastic or something like that. Now, this is important to understand. Behind the scenes, there's a scheduler that manages the movement of execution from one thread to another. It's that scheduler that does all the work of making it so that we're not wasting time. It's the ultimate bin packer for our threads, okay? That scheduler is by default 1 thread per core. So if you have 4 cores and you have 4 threads, and that's enough usually. That'll be just fine because it's only going to put work on the CPU. It's only going to put work on that thread just long enough to kick off the pipeline and then jump off the thread and let something else back on. Most of the time that your computer spends is going to be time spent waiting for bytes to arrive, right? So it's going to background that waiting. The computer, your operating system, can babysit, thousands or tens of thousands of file descriptors that it's pulling for new data much more readily than it can manage tens of thousands of threads. Okay, so this is what we're doing. We're trading a little bit of difference in programming model for that much better scalability. We're decoupling the number of threads from the number of clients. By doing that, we get better scalability. So I've got that scheduler there, and you know that you have to stay, you have to do reactive code only on that scheduler. Otherwise, you risk monopolizing that thread. Now, consider what that means. If you monopolize a thread and you've only got a scheduler with 4 threads, well, that means you've monopolized not just one user, but 25% of all users on that system. So it's super critical that you avoid monopolizing that thread. We give you a tool called Blockhound that you can use that helps you discover when you're making blocking calls from a non-blocking thread. This is very convenient to isolate or ferret out any kind of blocking silliness. So suppose you did something like this in a reactive pipeline. You said thread.sleep. Well, assuming you had installed Blockhound on the class path and then called blockhound.install right before public static void main, right after you started the public static void main, but before you called Spring Boot. If you did that, then Blockhound, the Java agent, would be nice enough to throw an exception whenever you do anything that might jeopardize your ability to scale that service up. This is ideal for figuring out where you're being silly. Now, keep in mind, you may have to do blocking things in your code. That's a given, okay? It's not like we can stop you. It is just Java after all. But we are giving you the tools to be very explicit about isolating that thing. You want to be able to isolate that to a particular scheduler. There are some schedulers that are meant to work like a classic thread pool. They just create new threads in perpetuity if you want them to, right? These are definitely not to be used for reactive calls because there's no point, right? I can just do reactive calls on a limited capped thread pool. But for blocking interactions where I might need more threads, you can use one of those. The responsibility to do that, to minimize the inefficient use of threads, has always been there, my friends. It's just that now we have the tools to do that much more readily. We've given you the ability to say, hey, this particular interaction is blocking. I need it to happen on this blocking thread pool, and I want to cordon it off and protect the rest of the scalability of the system. Now we've got our reactive sort of pipeline here. What I want to do is I want to be able to use it. I want to demonstrate it to you. So I'm going to create a quick WebSocket endpoint. Okay, so class WebSocket configuration. Here we go. And here I'm going to create a few beans. A WebSocket handler. Okay, a WebSocket handler is where our business logic lives. We're going to get back to that in a second. Okay, that's the crux of what we're trying to do here. And that WebSocket handler is going to use a greeting service. We also want to create a bean of type simple URL handler mapping. This is infrastructure, okay? This is actually what you have to do to tell the framework how you want to expose your business logic represented by that WebSocket handler, which we're going to inject here. The WebSocket handler is a bean that will actually produce the WebSocket protocol response, okay? And that's the bean that we're going to write up together. But when a client connects to the service, they're going to connect to an HTTP endpoint and then be upgraded to the WebSocket protocol. So they initiate their HTTP conversation at WS greetings or whatever other URL we had specified. And then finally, I'm going to create a WebSocket handler adapter. This is to tell the framework that you're interested in doing WebSockets and to be on the lookout for this kind of machinery, okay? Now, let's look at the WebSocket handler, okay? It's a very simple callback interface. It says when a client connects to the service, you should establish a session. And then you, programmer, my dear friend, can use that session to both read the data from the client and then send back data to the client, okay? So I'm gonna say to the session, I'm gonna ask the session, give me a publisher containing WebSocket messages. That'll be the names, right? We're gonna send a greeting to we're gonna send a bunch of greetings to a particular name. I'm gonna say for each WebSocket message, I wanna unpack the payload as text. And then for each one of those, I'm gonna turn it into a new greetings request. Okay, there's the name. Actually, I should, I use text, but it could have just been name, and it doesn't matter now. It's moot. It's a method reference. And then for each one of those, I'm going to turn that greetings request into a call to greetings service, like so. Okay, and that'll give me a stream of greetings responses. Now, what I want to do is I want to send that back to the client. So I'm going to take each greetings response. I'm going to map it into a text string, a string, and then I'm going to map that into a WebSocket message. Okay, so I use the session to create a text message that I can send back as a WebSocket frame to the client. Okay, replace that. There's the entire response, and I can just say session.send socket message flux. Now, that's the essence of it, but let's clean this up a little bit. Lambdas are nice. I like lambdas. Indeed, this whole thing could just be var data, and then this could of course be a method reference, and then that could be just this, and ta-da. Okay, data, good stuff. So there's the entire pipeline. Obviously I should have formatted it with a little bit more care. I apologize, friends. That was laziness on my part. If we can't be civil in our code, then where else can we? So let's do that. Okay, good. Now, there's our pipeline. That's the entire interaction. That's going to work. It's going to read the data in. It's going to send back a stream of responses back out. But in order for us to use this, we need to demonstrate that. And of course, that means I need to do something that I'm not proud of, something that I would not do, but for the necessity of time, for the expediency that it'll give us. And I certainly wouldn't otherwise do it in polite company. I don't mean to offend anybody, but I have no other choice. I am going to write JavaScript. So source main resources static file ws.html and HTML body script and window.add event listener. When the window opens up, when it's loaded, rather, I'm going to have a callback, right, that I'll use to then process the event, and therein I'm going to create a new WebSocket. Okay, WebSocket ws.localhost 8080/WS greetings. Okay, and there I'm going to say add event listener, and when the socket is open, I will then send back a name. I'll send to the socket a name, and of course I'll say DevDotNext digital. Okay, there's that. And when each response comes back, I'm going to listen for the response and write it out, okay? So console.log message.data. Okay, there's our pipeline, our client, if you will, simple though it is. Let's go ahead and restart that. Okay, I had my cup of coffee, my sip of coffee. We got ourselves a new application and console. There we are, my friends. Every second in perpetuity, that's going to produce a new response, and that's okay. It's going to go on and on and on and on forever and ever and ever. It has no end. It is endless. It is without end. It is like the oceans and the stars and the skies and the bugs in your code. Just infinite, my friends, infinite. And that's okay, because in between the raindrops, in between each new value that you perceive reflected in the output there, it's going to free up that thread. We're not keeping that thread open. Other things can use that thread to process work in between each second, in between each new heartbeat that's coming out of that service. This gives us much better scalability. And that, my friends, is the real value, the real win that we get by using reactive types, or by using reactive programming. Now, so far, all I've done is I've built a service that uses WebSockets and HTTP. I like both of these protocols, but I don't think they're particularly great fits for services. I think they're good fits for document retrieval. So one thing I've become quite fond of is this protocol called RSocket. RSocket is a separate protocol. It's a binary protocol that is payload agnostic. It doesn't care how you represent the payload. It has headers, which WebSockets do not. It has support for all the different sort of messaging exchange patterns, which HTTP does not. So things like fire and forget, things like bidirectional communication. It also keeps, it's also stateful. So when the client starts up, or when one node connects to the other, it stays connected through the life of the application. And that connection is multiplexed, not just pipeline, but also multiplexed. So it's very efficient. You don't have to do the constant network connection and ACK and all that stuff. You just stay connected, right? It makes it a lot faster to exchange data from one side to the other. It's also fully reactive on the wire. Remember, with HTTP, if a client disconnects from an HTTP service, all that HTTP service, if it's reactive, all it can do is cancel the production of the pipeline that was, the production of the data from the reactive stream that was being used to feed back to the client. There's no outcome. There's nothing else that it can do besides cancel. It cannot stop and suspend and then resume processing an hour later, as a truly reactive thing could and would do. So what I want is something that supports this new way forward. And RSocket can do that. RSocket was a protocol that was developed by engineers who were at Netflix, who then went to Facebook. It was forged in the production, it was forged in the fires of production. So it has good operational ability. And so it's trivial to use this protocol. It's a binary protocol, it's a network protocol, but there's a number of different implementations. One of which for Java was the Java implementation was implemented using Project Reactor. And we've incorporated that into Spring Framework itself. So you actually have that in the last GA version of Spring Boot 2.2. You don't even have to use 2.30. And so you can say controller, for example, and then you map this endpoint like so, greetings, etc. Okay, so I've got an endpoint. And what I'm going to do is I'm going to just tell the framework to expose this endpoint here, RSocket, and I'm going to run this on port 7070, or it's just an arbitrary port. It can be anything you want. I'm going to restart that. And now I'm going to build a quick client to connect to that, okay? So we're going to go back to start.spring.io, of course. And here, I'll use 2.30, and I'll use Kotlin because hashtag I love Kotlin. And I'm going to build a client such as it is. Now all I'm going to do is bring in the RSocket support here. I don't really need anything else, okay? And if I go down to the client, assuming I can, here we are, downloads. Okay, UAO client. Okay, CD client, Maven install. Yeah, sure. I thought you had that permission before, Java. Uh-oh, did they update the Kotlin stuff? Good thing I've got fiber, huh? Fingers crossed. You know, if I could whistle, this is when I would do it. But I can't. It looks like it's gonna be okay. I got a feeling about this. It looks like it's already nearing the finish line. We've still got 2 minutes. That's an abundance of time. Perhaps the good doctor will give me a minute or two extra after the clock strikes 50. Okay, looks like it's up and running. So now, file open. Okay, downloads, client, pom.xml, do this the old-fashioned way, open as a project. And so all I want to do in this application is demonstrate that you can use Kotlin from your application. Actually, I'm going to go a step further. I'm also going to build a simple HTTP endpoint. So to demonstrate that you can bridge this stuff. So I'm going to use Spring Boot Starter Webflux. That's the reactive web runtime. I'm going to bring that into the application. Hit enable auto import. And in my client code, I'm going to build an application that uses data classes, which are kind of like Java 14 records. They're very convenient. And I'm going to build a greeting request val name string, okay, and a data class greeting response val message, okay. That's the DTO I'm going to use to describe the data that's being marshaled across the wire. And then I'm going to build a some code that actually uses a client for the RSocket endpoint, so RSocket requester, and I'm going to use RSocket requester builder, RSocket requester.builder, rsrb.connect TCP. I'm going to connect onto host 7070, localhost and port 7070. Okay, and I'm going to say create that. Okay, so all I've done is I've defined a function that's going to return a bean just as you would with Java configuration, and now I can use that to actually build an HTTP endpoint. And here I'm going to show you the functional reactive style endpoints that I showed you before using the nice Kotlin DSL that you have here. But instead of using router, which is the API that we'd use if you were using regular functional reactive endpoints, since we're using Kotlin, we can also use coroutines. Okay, coroutines make it so that we can write code that looks like regular imperative code, and yet not have to manage that that extra sort of programming, right? It looks like regular line 1, line 2, line 3 behavior instead of the map and flat map and the functional reactive style that we've been seeing so far. So greetings names, okay, name, and then for each response, I'm going to produce the response, I'm going to inject my RSocket requester, okay, and I'm going to make a call. So I'll say rsr.route, and the route will be greetings. That's the endpoint that we annotated there before. The data that I'm going to send in is a greetings request, and the name will be DevDotNext digital, okay? And the data that I expect back will be a reactive stream of type greetings response. And notice that we have reified generics or pseudo reified generics here with Kotlin and the, thanks to this extension function. And because it's going to give me back a reactive stream, if you look at the type that I have there, that's actually just a reactive stream, and it's a publisher of greetings response. But I just told you that you don't need to write this kind of code anymore, right? You have coroutines, and that's true. So now we have a nice thing here called await, okay? And actually what I want to do is I want to get the, turn that there. I want to flow, okay? That gives me a flux of greetings response, or I can actually wait for a single one. That's a more concrete example, so you can kind of see it in action. So let's go back here and create yet another endpoint that returns, well, you know what, that's not gonna work. We don't have enough time for that. Let's go back here. We're gonna take that reactive stream of data that we've got back and turn it into a flow, like so. This is a type that you would get from flow. As flow, this is a type that you get from Kotlin, and you can use it kind of like a flux, but you can also, if you're not using the reactive APIs, you can also treat it like a regular collection. So server response.OK.body value, okay, or body and await flow, retrieve flux, and there you go. Okay, there's the entire pipeline. So let's see if that works. Here we go, put that in there. Good. Okay, so response. Let's restart this and see what we get, my friends. If I were using a endpoint that returned just a mono, I could write code that says, hey, I've got a val of reservation. I've got a variable that's type of type reservation. It's equal to this asynchronous reactive call, and that call would be turned into a callback, a call plus a continuation, which is a callback. So server port, I'm going to run it on a random port here, port 9999. You don't really see that behind the scenes here, but coroutines make life a lot simpler, okay? Okay, that's on port 9999. Now, let's try it. Curl HTTP localhost 9999 / reservation. Sorry, did I say greetings? I think it's greetings. Oh, and I also want to turn this data into, I want to give it a content type. I forgot to do that. So content type is media type, application JSON or text event stream, right? So text media type dot text event stream. There we go, text event stream. Okay. Is it up? Looks like it's up. Greetings. And the request is not the, I'm going to send in a string. So it'll actually be it.path variable .name. Okay, that's the actual thing. I'm going to parameterize the invocation there. Restart and greetings dev.next. Okay. Uh-oh. Closed. Did I do something wrong? Error receiving frame. $70.70 looks legit. Oh, message. What's the issue here? Data is a greetings request coming in with a name. Going to the greetings endpoint. I'm expecting a greetings response back as a stream. I take that data and I send it over to the other side. And then respond with that. Connection reset. I'll restart that. I'm not sure what that is, but let's just try again. Okay. Restart that. Don't care. Just want to see if it works. Greetings. Localhost. Localhost. Oh, it's Jackson. Son of a gun. Okay, let's try this again. This is the problem. I got too cute. I did it to myself. I should have used the, there you go. Let's see if that makes it a little bit easier. That should be easier to serialize. Restart the client. I missed out. There's a binding library that if I had remembered to just specify the reactive web stuff on the initializer, would have for sure been on the class path, but I didn't do that. Remember, I added that reactive web stuff retroactively. And so the result is I didn't get all the right dependencies here. So let's just copy all of that, go back to my build in the client, paste all that there. Greetings request, I can go back to this, I think. So data, class, greeting request, val name string, greeting response, val message string. Okay. Fingers and eyes crossed. There we go. There we go, my friends. I forgot the serialization libraries. Silly me. The lesson here is just use the Spring initializer. Go to start.spring.io, you'll get response. So my friends, we have data that's being sent across the wire using the RSocket protocol. The data is arriving there. Each new record in turn being serialized as the binary protocol being sent from one RSocket client to the RSocket service. Then I'm chaining it to the service and event stream endpoint that I'm creating that emits application text event stream. I want to thank you so much for your time. Obviously, I bungled the demo in there in the last few yards of the game, but I'm happy to answer more questions here. Let me turn to those right now. Let's see. Why is there? I hope.
Hey, Josh, can I read a few questions for you?
Please, yes, sir.
All right. Hey, thanks again for doing this. Really appreciate it.
Thank you, sir.
I don't think we'll have time to read all the questions. We'll take as many as we can. Very first question was the traditional annotation get mapping approach and the annotation router function. Are they the same? Is it just syntax sugar?
Yeah, it's just an API. You can use either one.
More?
Either one is okay. One is right. Both produce reactive endpoints, and they're both HTTP. They're just it's up to, and they're not exclusionary. You can do either one. Okay. You can do both. I mean, same apps.
Okay, so do we have to use mono or flux all the way through our service and the DAO layer to be fully reactive? Regular Spring data repos use optional or list, and it's not clear if we can continue using those types with Spring reactive repos.
Behind the scenes, those drivers, the traditional Spring Data, MongoDB, Spring Data, Cassandra, etc., block. So they're doing synchronous blocking I/O. What you want to do is use the Spring Data reactive MongoDB, which is a separate project, separate foundational layer, separate driver, separate everything, and that's going to be non-blocking all the way down to the I/O layer for the database. And so, you know, it's not a drop-in replacement. I cannot promise you that. It's going to be some changes into your code, but the benefits hopefully are persuasive.
So that leads to another question. I am also curious how to handle the mono and flux types in a clean architecture. Will I be passing these types from the REST layer down until I reach the domain layer? Typically in the domain layer, I only want to use POJOs and as less library as possible.
Sure. Consider flux and mono your new collection. What I normally do is I accept reactive streams publishers and I return flux and mono, but you can just return publishers as well. And it's just a little bit less clear, right? If people can adapt it to a Akka streams or a RxJava or a Vertex type from given a reactive streams publisher or given a Java util concurrent flow type, right? Flow.publisher. Actually, you can use the JDK types as well.
Yeah, so you don't have to depend on Spring-specific interfaces. You can go up one level with the interface.
Yeah, you can use the reactive streams types, which is fine. That supports Java 8, or if you're happy, depending on Java 9, and why wouldn't you? You can use Java util concurrent flow.publisher, subscriber, etc. I like the specific types because they give me semantics. They give me a distinction of whether there's more than one value in this thing or not. But if you can figure that out, and then you can just cast inside the code. You can accept publishers, but return publishers or return specific ones if you want more, more semantics.
Next question, is there a support for gRPC?
Yeah, there's actually, so Salesforce built a reactive, a project reactor-based compiler plugin for gRPC. So it's called ProTalk. It's a compiler plugin that is built by Salesforce. It's not something that we recommend. I wouldn't, given RSocket, I don't know why people would use gRPC. RSocket is faster, it has better scalability. It's been, it's been built with operations in mind, and it's truly reactive. It's not, and it's also not code generation. You don't have to give up your API design just because the ProTalk compiler says so. But it does work. The Salesforce thing works nicely. Good job to that team. And they're using Reactor as well, so that's cool.
Hey, Josh, thank you so much for your time and for helping us to learn a little bit deeper into reactive. I really appreciate it.